Hi guys, this is the video for Thursday where our focus is the normal distribution. It's also known more commonly as the bell curve. So you've heard about the bell curve. A lot of teachers, they talk about grading on the bell curve or grading on a curve. And so that's where most of the scores fall in the middle, and then the equal amount of people that did not so well and very well. In reality, that is not actually at all what most grades look like, but you usually hear about the bell curve in normal life and also in reference to grading. All right, so let's go over example 1. I put this graph, this image on both your note catcher and your work time because these percentages you're going to keep referring back to while you're working the problem. So the numbers that you're going to use come straight from that these numbers up here. So we're going to use the image above, and we want to know, for example 1, what lies within 1 standard deviation of the mean. Okay, so I want to show you within 1 standard deviation of the mean is 0. That's the middle. So these are -1 and +1 mean they're 1 standard deviation below the mean and 1 standard deviation above. So you'll notice that I have a 15, a 19.1, 19.1, and 15. So that's what I added, 15, 19.1, 19.1, and 15. In other words, if you're looking above and below, so they're within a certain distance of the mean, you could literally just write what's below and then double it. So either writing them all out or writing half of it and then times 2, you get the same answer. And so 68.2% of your data lies within 1 standard deviation of the mean on a normal bell curve, in a normal distribution. Well, then the next question says, well, what lies within 2 standard deviations of the mean? Okay, so let's look back up here and see where -2 to +2. So every number you see between my fingers is what we're going to add. So within 2 standard deviations of the mean is 4.4% of the data plus 9.2 plus 15 plus 19, and then the numbers just repeat. So 4.4 plus 9.2 plus 15 plus 19.1 times 2 means that the data in a normal distribution is 95.4% of all data falls within 2 standard deviations of the mean. All right, so then it says, well, what's more than 3? So more than 3 standard deviations away. All right, so if you look over here at 3.1% is more than 3 away. And if you go in the negative direction to -3, another 0.1% is more than 3 standard deviations away from the mean. So all you have that's more than 3, so now we're going to cover the middle, and more than 3 is 0.1 and 0.1. And so 0.1 times 2 is 0.2%. So very, very little data is more than 3 standard deviations away from the mean in a normal distribution. Finally, it says how much of the data, what percentage falls between 1 and 2 standard deviations above the mean. So now we aren't looking at anything below the mean. We're literally only looking above the mean. And it says between 1 and 2. So I'm covering up everything below 1 and everything above 2. And all you can see is 9.2% and 4.4%. So altogether, 13.6% of the data falls between 1 and 2 standard deviations above the mean. Okay? All right, so number 2. Example number 2. Let's cover some of this up because it gets really busy. So it says, as you can see from example 1, the majority of any normally distributed population will lie within 1 standard deviation of its mean, and the vast majority will fall within 2. A whole variety of problems can be solved if we know that a population is normally distributed. So you have to know that it is before you can apply anything from that table that we just looked at, from that graph. So this is at Arlington High School. 424 juniors recently took the SAT exam. On the math portion of the exam, the mean score, meaning the average, was 540 with a standard deviation of 80. If the scores on the exam were normally distributed, so that means they actually, for sure, we know that they fit this curve right here. So if they were normally distributed, answer the following questions. Okay, so we're going to use what we know. What percent of the math scores fell between 500 and 660? Okay, well, for 500, we know that 500, the average was 540. So anytime we want to know this, we take the average minus the number, unless it's bigger, and then it's the number minus 540. You'll see that in a minute. But the average, which was 540, minus the number divided by standard deviation of 80. If we divide that out, we find out that it's 0.5 standard deviations below the mean. Okay? So we're going to use that. All right? Well, for 660, you do 660 minus the mean, which is 540, right there. And again, you divide by 80 because that's our standard deviation. And you find out that it's 1.5. So 1.5 standard deviations above the mean. All right? So then if we go to that table that I'm going to put back up here, we're looking between 0.5 below and 1.5 above. Okay, so let's go look at this. 0.5 below and 1.5 above. Look at the numbers. That's the percentages we get. 19.1, 19.1, 15, and 9.2. So let's go look at that. 19.1, 19.1, 15, and 9.2. Those are the numbers that fell between 0.5 below the mean and 1.5 above the mean. And that tells us that 62.4% of the math scores fell between 500 and 660. All right, so then this one's related. It says, well, if we know what percentage of the scores fell between 500 and 660, how many scores is that? So in other words, what is 62.4% of the total of 424 students or juniors that took it? So 0.624, because you have to convert to a decimal by moving the decimal 2 places to the left, times 424 is this number, which rounds to about 265 students had a score between 500 and 660. All right, I know this seems a little fast, so you can rewind it or you can come to my office hours today and definitely ask me some questions. So let's look at part C. If Evan scored a 740 on her math exam, what percentage of the students who took the exam did better than her? Well, first of all, we need to find out how well she did on the chart. So she got a 740. So again, we compare that to the mean. So 740 minus the average, which was 540, divided by the standard deviation, which was 80. Okay, so I'm going to scroll this back up. So 740 minus 540 divided by 80 equals 2.5. So her score was 2.5 standard deviations above the mean. All right, so let's look at that. 2.5 standard deviations above the mean. That's right here. So who did better than her? Well, not very many. 0.5 and 0.1%. So if we look over here, only 0.6% scored higher than Evan did. Well, how many students is that? We know the percentage that scored higher, but how many students is that? So just like part B, we want to find the percentage, that the 0.6% in this case, of the 424 juniors that took the test. So 0.006, again, convert to a decimal by moving 2 places to the left, and then multiply by 424, and we find out that only about 3 students out of all 424 juniors did better than Evan did on that math exam. Awesome. All right, so this is getting a little long, so I'm just gonna show you examples 3 and 4. They're worked exactly the same way. Basically, Jabari is 72 inches tall. The mean is 66. The standard deviation is 3. So you subtract his height minus the mean divided by 3 and find out that he is 2 standard deviations above the mean. So you go over to 2 standard deviations above the mean, add up those 3 numbers, and you find out that about 2% would be taller than him, which means that if you subtract that 2% from 100, you find he is in the 98th percentile. And finally, and I hate to rush, but I also don't want to make the video too long. Again, you're welcome to ask me questions or get some help from me or just rewind this. But we have, we want to know how many would have less than 11.1 ounces if they have an average of 12 ounces and a standard deviation of 0.6, and there are a total of 250 cans. This is just like the earlier ones. For 11.1 ounces, we subtract that from the mean and divide by the standard deviation to find that 11.1 ounces is 1.15 standard deviations below the mean. So you go to that chart and you find everything that's below 1.5 standard deviations below the mean. So that's all of these numbers right here. So I took all of those numbers, added them up, and said that 6.7% are below that 11.1. So because I wanted numbers of cans instead of percentage of cans, I just do that percentage times the number of cans and find out that 17 soda cans have less than 11.1 ounces in them, or number 1. I hope that helps. Once you get some practice with this, I think you'll find it easier. It's just a lot of taking your number and subtracting it from the mean, or if your number is higher, taking your number and subtracting the mean from it, and then dividing by the standard deviation, and then going back to that chart over and over. All right, I hope that's helpful. Please, please reach out if you have any questions, either through email or in my office hours, and I will see you soon. Bye-bye.